Let's go ahead and get into what we need to. So before we talk about the graph that I had you do during third period, before we go back and revisit example 1B here, I do need to go through and do our definition of the vertical line test first. Okay? And then my hope is this. Yesterday we talked about domain, range, relations, and functions. And we talked about how to use a mapping diagram to help determine what was a function and what was not. All right? And that is a great tool to use if they give you a table or if they give you a set of ordered pairs. All right? Those are not the optimal tools to use if they give you a graph, which is what we're going to start talking about today. So I am going to tell you that when you go to take your assessment on Friday, I'm going to expect you to use one method given one problem and another method given another different problem. You can't mix and match. You got to know when to use what. Okay? So let's talk about what the vertical line test is. It is a lengthy definition, and it is a confusing definition, I'll be honest, for most students, until you see exactly what we're trying to talk about. So here's what the vertical line test tells us. It says that for a relation represented by a graph, okay, that's where we're going to begin. This can only be used if you have a graph. You cannot use the vertical line test if you've been given a table. You cannot use the vertical line test if you've been given a set of ordered pairs. This only works if you graph, okay? So for a relation represented by a graph, if any vertical line okay, what's a vertical line look like? Straight up and down. Okay, remember, horizon is horizontal, vertical is the other one, okay? So if you don't remember what a vertical line looks like, we'll add that as part of it there, okay? If any vertical line passes through more than 1 point on the graph, then the relation is not a function. Now, if it doesn't fit that scenario, then guess what? It is a function. Okay? But if you draw a graph and any vertical line crosses through more than 1 point on that graph, then you know that it is not a function. Okay? So, now I'm going to go back and we're going to review at the top of the back page. Go ahead and flip it over because we're going to take a look at the back page of our examples here. We're going to go back to example 1B. Okay? And I chose example 1B because if you graphed all of the ordered pairs there, it fit nicely on one piece of one graph. Okay, example 1A, the heights of the trees were too tall, so that would have been a pain to graph. We went ahead and we just graphed these. Now, if we recall from what we did yesterday, we did example 1B where we used the mapping diagram. And we were able to determine that this is not a function, okay, because this input of 6 has two outputs. And that's what caused it to not be a function, okay? Let's look and see what that looks like as a graph. So, Evan, tell me, what's the first point in the table in 1B that they gave us? In example 1B, they gave you a t-table, right? What's the first ordered pair they gave you? What's the first x and the first y? 2, 0? Okay. 2-0. Okay, and what was my second one?
6-4.
6-4. Okay, that was right here. Jacinthia, what was the second or third one? What's that? Well, look at your notes. I don't have them right in front of me. What's the third value in that table?
Yeah, 5.
Okay, 5-1. Hayden, what was the fourth one?
3-4.
3-4. And Bryce, what was my fifth one?
Our fifth one is 2, -3. Oh,
So looking right here. What's the fifth value there?
6-0.
6-0.
Yeah.
All right, so hopefully everybody, that's what the graph of that one looked like when you got done, right? Now, here's how you're going to use the vertical line test. Take your pencil, make it into a vertical line. Okay, straight up and down. Okay? Start over here on the left-hand side, and as I move this through, we have to always ask ourselves, does this touch more than one point at a time? Okay? So I'm going to use this as my vertical line. Does this ever touch more than 1 point? Like right here, how many points is that touching? It's just touching 1. Okay, right here. It's only, how many is it touching here?
1.
I'm hearing 2 and 1. Okay, it's only touching 1. How many is it touching here? 1. How many is it touching here? So is this a function? No. Because according to the vertical line test, if any vertical line touches more than 1 point at the same time, it is not a function. So here's what I can tell you for this justification, and we'll do this later, but this is how we're going to write this one now. Okay? We're going to be able to say, according to this graph, this is not a function. I'm not going to use this over here. I'm going to say it fails the vertical line test. And that's what we're going to say. This is not a function because it fails the vertical line test. If I wanted to say that it is a function, I'm going to say this is a function because it passes the vertical line test. That's it. I'm not talking about inputs and outputs because when it comes to a graph, we're strictly using the vertical line test. Okay? Two completely different explanations because I'm looking at it in two completely different ways. One with the mapping diagram, one with the graph. Now, the reason I have both of these up here together is to see that we can have two different explanations that both work. But I also want to show you the connection between these. This is why the vertical line test works. Okay? Where at on this graph did we run into problems? Right here, right? So where is that at on the x-axis? Which number is causing us an issue? 6. Why is it causing us an issue? Because of this. Because it has two outputs. This has an output of 4 and it has an output of 0. The vertical line test is your visual cue that shows that something has two outputs. Okay? We didn't have an issue right here. Why? Because 2 only had one output. We didn't have an issue at 3 because 3 only had one output. We didn't have an issue at 5 because 5 only had one output. The issue that we have is right here at 6 because 6 has two outputs. I don't want the vertical line test to be some unknown magic trick that just works. There's a reason the vertical line test works. It is a graphing way or a picture way of showing a mapping diagram ultimately. Now, it also helps you when you start to get, because again, we're going to kind of up the ante when you get to ideas of like this, when you get to Algebra 1. Sometimes you're not going to be able to create a mapping diagram. You're just going to be given a graph and asked, is this a function? this will be the only thing that you can use in that idea. Okay, and we're going to have to be able to use the vertical line test in order to be able to test that. All right, does that make sense to everybody? Again, I'm trying to draw a connection. I didn't want to do all of this yesterday, but trying to connect between what we did yesterday and what we're doing today. All right, so let's go to example 2A. Yep, you can just keep that graph paper. I don't know if we'll need to begin right away or not, but you can keep it kind of in there loose. So in example 2A, it says use the following ordered pairs, identify the domain and range, then determine if the relation is in the function and explain why or why not, and I'm specifically giving you a graph. This is my way, without telling you what you have to use, this is my way of telling you, I expect you to use the vertical line test. If I don't expect you to use the vertical line test, then I'm going to give you the mapping diagram that we have like in example 1B. Does that make sense? On your assessment on Friday, these are both going to be on there. You need to know when to use what. Okay? So, domain, Chloe H, is which coordinate? The x or the y? The x. Quentin, what's our rules when listing domain?
There must be ordered from least to greatest and no duplicate numbers.
And no duplicate numbers, no repeating numbers. So as we go to list our domain, what's my smallest x coordinate we have up here? Negative 3 followed by? Negative 2 followed by 1 followed by 2, correct? All right, our range. Smallest, if our domain is our x's, our range must be our y's. Our smallest y coordinate is negative 3 followed by negative 2. Negative 1?
No,
Just 1, 2, and 3. All right, now graph all your points. All right, they gave you 5 ordered pairs to begin with, so you need to make sure that you got 5 points plotted on your graph. You got to be able to graph these accurately. Okay? Now again, your vertical line test is your pencil test. Start left or right, wherever you want to go, make sure that your line is vertical. Okay, is it touching 2 points here? No. Is it touching 2 points here?
No.
Is it touching 2 points here?
Yes.
So what's that tell us? It's not a function. I don't even need to worry about the last part of it. As soon as I find any spot that it's touching 2 points, this is not a function. So what we're going to be able to explain here is this is not a function. It fails the vertical line test. You don't need to even tell me where it fails it. You just need to be able to explain to me that it fails it. Now, where does it fail it at? Just so we know. At 1. And if you were to look at it, and create a mapping diagram, which I'm not asking you to do, you're going to notice the reason that it fails it at 1 is these 2 ordered pairs right here. The first ordered pair says that 1 has an output of 1, and the second ordered pair says that 1 has an output of 3. And so that 1 input has 2 outputs. That's what's making this so it is not a function. All right, I want you guys to try example 2B. On your own, list the domain, list the range, graph it. Is it a function? Why or why not? All right, after you start with this, what is the domain of this function or relation?
-2, 2, 3, 4, 6.
There we go. In order, least to greatest, no repeating values. Come on, give me my range.
0, 1, 2, 4.
Okay, now here is something I'm going to talk real quickly about. Like, and Delaney kind of pointed it out earlier on. We were able to actually say early in period 3, something wasn't a function because, like, there were more outputs than there were inputs. Okay? You can't do that in this one here. There's more inputs than outputs, but that doesn't mean that it is or is not a function. We really won't know until you either create your mapping diagram or until you graph it in this particular case. Okay? So let's go ahead and graph our 5 ordered pairs. So we've got 4, 2 right here, -2, 0, 6, 4, 3, 1, and 2, 4. Okay, so if we start from left to right, how many points is this touching? 1.
1.
So what's that tell us? It is a function because it passes the vertical line test. That's exactly what we're going to be able to write. This is a function. It passes the vertical line test. Okay, now here's my biggest obstacle that I have, because we do this in Algebra 1, but like I said, we just can't, we do this, the functions just look a little bit more complex. That's it, okay? But I get students that try to use the vertical line test as an explanation when they create a mapping diagram. That's not going to work. The very first part of the vertical line test says when what? When a relation is represented by a graph. If you do not have a graph, you are not using the vertical line test. If you do have a graph, then we are using the vertical line test. Okay? So what do we do if we don't have a graph? Then we're using a mapping diagram. And we go back to the same idea we talked about yesterday. Does each input have exactly one output? If it does, then it's a function. If it doesn't, then it's not a function. Okay? So the same thing is being tested. Is this relation a function? But we've got two different ways to be able to explain it. You need to make sure you know what to explain when. Okay? All right, your homework assignment for this evening, and I'll get you some graph paper here in a minute, is going to be page 403, numbers 2 through 20 even. Okay, we did most of the odds for these, now we're asking you to do the evens. I am going to point this out. There are some problems, I think there are two in particular, where they ask you to both create a mapping diagram and a graph. Okay? Yesterday I wasn't worried about the graph part of it because we hadn't talked about the vertical line test. Today I want you to do both. Okay? And the reason being again is I'm trying to get us to understand the relationship between what's a function and what's not between these two scenarios and why. Okay?